So is that a silly question? It's good to have questions. Nothing wrong with that.
Nope. I have like part of 1.2 in there.
Okay. So, any questions? I like that a lot of you guys got homework done. I guess it's going okay then, right? I mean, chapter 1 depends on what you're coming in with, how long it's been since you've taken math. Chapter 1 should not be too intense, right? We're going to get a little more intense today. Tiny little bit. If there's no questions, we're going to right into it. Yes? Yes. 1-3, there's no one thing I can say. It's all about, like I said, it's all about, can you take the numbers out of the context and use them in the right way? That's really what it is. It's not word problems. There's not a single word problem in section 1-3. You could use algebra on some of them if you wanted to. You don't have to use algebra on any of them if you don't want to. There's always another way. Sometimes algebra is the best way. But it's not the only way. You guys with me? Okay, yes?
What does E30 mean on that?
Oh yeah, what is E30? Every third one, good. I think I said that. I made that joke about don't think it's every third odd or else you'll get done with homework quick. But I'll tell you, what the hell. So every third one, it should say at the top of the homework sheet, it gives you examples.
I think I lost. You don't have an extra one, do you?
Yeah. Is it every third one like 147, 369? Every third one. It's okay if you get off track every now and again, but try not to do that too much. Because when I grade and all of a sudden somebody has totally different problems, I'm like, oh shit, I don't know.
So on the 3 through 30, it's every third one?
3, 6, 9, 12.
Yeah, I wish we were listening.
If you do more, it's not a problem. I mean, that's just more practice. Yay for that, but it'll just set you back. Right? It's just, all right, good. You good now? It's a good time to catch it now instead of, like 4 weeks later. All right. You guys doing all right? I'm sorry. You all look at me like, just let us go, man. No.
Oh, it's right there on the top.
All right, so any questions before we get into chapter 3? We're going to get into logic. Yes, ma'am.
This is like about, are the tests just kind of to be announced, like whenever we...
No, they're on the homework sheet. They're listed on the homework sheet. Look at where the dates are.
Oh, okay.
Yeah. And like I said, I'll only change the dates.
No.
I'll try not to change the dates. Can you see them in red?
Yeah.
Cool.
No,
All right.
There's no quizzes.
There are quizzes. I just don't list those. I don't do pop quizzes, so I'll let you know. So today I'm going to tell you we're going to have a quiz. I'll tell you right now, so don't forget. There's going to be a quiz, chapter 1, on Wednesday. Like quizzes are normally like 6 problems long, or roughly somewhere around there. 6 to 10, based on how difficult the problems are. I try to make them really basic, really bare bones, just straight to the point. Are you getting the basic idea, right? And then don't forget I give practice tests before the review day, all right? Okay. All right, so if there's no questions, any more questions on how things work in the class? Any questions from homework? All right. I'm really sorry if I'm the one depressing you. Somebody's depressing you. Some of you guys look really depressed. I'm sorry. All right. So we don't do chapter 2. We hop right over that. We go right into chapter 3. And just to give you a little background. So a couple things real quick. Math in general, it's not necessarily that every single thing you learn in math, and you know this already, you might not use a lot of what you learn in some math courses. But the more that you know about math, the more you have at your ready in case you do need to use it. There's a lot of jobs where they give you a little math quiz. I don't know if anybody's ever had that happen to them. It happened to me. They give you a math quiz just because they know you're going to have to figure stuff out on the go, right? So they want to make sure that you understand some basic math. And they can get a little up there. Yeah. So where were you? Do you remember?
I mean, I'm still working there. I work at Victoria's Secret, and I work at the registers, and it's like...
They had to give you a math
Yeah,
quiz
they give us a math quiz.
when you went to apply for it?
Yeah.
All right. They just want you to be able to... The registers are old style?
I mean, they're touchscreen.
Okay. All right. Just wanted you... Okay. I like it. Cool. That's the last place I would have expected to be keeping math alive. It's Victoria's Secret, but I'll accept it.
You use it a lot.
Why not? Yeah. Okay. So logic, this is where people really feel like we're just being evil, but logic is where English and math intersect. Right? So on one level, it's remarkably simple because normally if you have an expression, if you have something with x's and y's and z's, how many things could x and y and z be? How many values could they have? Infinite number of values. Holy shit. So in logic, the variables we're going to use are taking the place of statements. And those statements could only be one of two things. That could either be true or false. So if anybody does any electrical work at all, anybody do any electrical work? No? Anybody know about zeros and ones? Or if there's current in a wire, it's called a 1. It's like true. And if there's no current in a wire, it's called a 0. And of course, what uses zeros and ones? Computers. I like it. Computers, man. But that's why they use zeros and ones, because they're the very most fundamental thing. If you ever do a computer class, this is kind of cool. I took a class, one of my best favorite classes. We built a computer, a little tiny computer, and we had to do something where you gave it a Lego and it moved it somewhere, and then we had to write the program for it to do that. But you start to use these little things, and it's all about: is there a current on this wire or not? And everything you do on a computer is based on billions of those, trillions sometimes of those little reads. So we're going to talk today about, so what if both wires have a current? What if only one wire has a current? And we're going to talk about it in the sense of true and false instead of 1 and 0. All right, so everybody sort of with me. I just want to give you kind of a broad overview of what you could use this for. Anybody ever taken a philosophy class? Philosophy. You guys might have done some logic already, like if-then statements and or and stuff like that, right? Truth tables. You ever done truth tables?
Yeah, and then there's the charts.
There you go. Look out. So some of you guys have a leg up, which happens in almost every class. Like when I took art class, and this kid next to me had like, his whole life had been painting, and me, it's like the first time I've ever held a brush in my life. This seems fair, but it happens. So if you've had philosophy before and you've done some logic before, you're a little bit ahead. Enjoy it while you can. Right? The rest of us, let's get caught up with what the hell's going on. So, first thing I want to talk about real quick, we're going to talk about stuff like or and what they mean more mathematically. But I want to make sure that you understand there's two different ors in the English language. I don't know if you guys know this. There's the or where I say you can pay $800 now, or $45 a month for 20 months. Right? That's that or. We see that or all the time. Is there any way I would do both of these things? Would you do both of these things? Here, no, let me give you $800 and I'll pay $45 a month. Yeah. No, this is just one thing. You're buying, what costs $800 now? You're buying like a really simple laptop, right? You with me? You're buying a laptop. You can either pay them $800 now, or you can pay $45 a month for 20 months, a little payment plan, right? Now, this plan, you would pay how much total? How much money total would you pay? $900. So you pay $100 extra. That's the extra little financing fee, whatever. You guys kind of with me? Would you ever do both? Would you just elect to do both? Would they expect you to do both? They would go, holy crap. Are you okay? They'd say, you sure, sir? Yes. Fine. Yeah. Pocket the $800 and then say that they're on the payment plan. It's not going to happen to you. Don't be hopeful if you work in retail. Right? Never somebody does that. Right? Maybe some of the stuff there they have to put on layaway. I don't know. So that is called the exclusive or. Exclusive or, meaning it can only be one or the other, not both. Right? So what options do you have? You could not buy it, Or you can pay this, or you can pay that, right? You can't do both. You're not going to do both. You kind of with me? That's the exclusive or. You with me? Either you can come with me or you can come with me. You've only got one spot left. You can't both come. So what we're going to use in math, what's used more often is the inclusive or. Which makes sense. It's inclusive. So it says we're not going to exclude the option that you can be both. So if I said I just need this place clean, you or you, I don't care who does it. Could both of you do it? Could both of you clean the room? Of course. I just want it clean. You or you clean it, and then you start cleaning it again. I'm like, not both of you. No, I'm going to go, sweet. It'll be done quicker. Are you guys with me? The difference between inclusive or, exclusive or. So we're going to use this. When you see or in chapter 3, it means that. Which means it could be both. Okay, maybe. All right.
So in the chapter, it could be true and false. Is that what?
No. So what I'm saying is, if I said you or you clean this room up, right? When's the only time the room won't get clean? If neither of them do, right? So this maybe we'll make this our first little step. So if it said statement 1 and statement 2, well, let me see, what's a better way to do this? Let's just use what we're going to use. I'm going to use P and Q are my variables. And if we have more statements, that would be R, S, T. Oh my God. Let's not go there yet. Let's just have 2 statements right now. So just like the letter X could take on any value of numbers. P and Q can take on any value of true or false. So there's only 2 values you could take on. Now P could represent a statement, but that statement could be true or that statement could be false. So P could be the statement, Jim cleans the room. And Q could be the statement, Tony cleans the room. You with me? Okay. So I'd say P, Q, P or Q. So it looks just like XY table, right? So now let's try this out. So tell me, does the room get clean if that P is true? If P is true, what does that mean? If P is true, what does that mean? Jim cleaned the room. I like it. Q is also true. So did P or Q? Did P or Q do it? Yeah, sure. One of them did it. Both of them did it. So one of them did it, right? So P or Q would be true. The only way P or Q would be false is if they were both false, right? Well, what else could it be? P could be true and Q could be false. But still, did P or Q do it? Yeah, P did it. So P or Q did it. You guys with me here? So if I ask you, did you place in this class or did you pass the last class? And you say yes, it could be either one of those. It could be both of them. Right? You passed the last class and you took the placement test for some reason, just for shits and giggles, and you passed it. And you placed in here. You did both. Why not? Sure, you could do that. I don't know if you guys... So what else could happen? What's the only thing I left out here?
F and T.
Good, I like it. So doesn't that feel like an XY table? But you're using true and false instead of every number imaginable, right? So this is what an or... So false or true. He did not clean it, but he did. So it's still true overall. False, false. Oh shit, room's still dirty. No good. All right, how are we feeling so far? That's our first little step, a little bit earlier than I wanted, but just because I keep talking about it, maybe it's good to see an actual example. This is what a P or Q table looks like. Truth table. All right, I like it so far. Yes?
So the question here would be like, what is the room clean?
When is the statement true? The statement, what statement does this represent? Jim cleans the room or Tony cleans the room. When is that statement true? These 3 situations. When's the only time it's false? This one. So the question would say, create a truth table for this situation. So you'd write all the possible values. What is the possible value of any statement somebody makes? It could either be true or it could be false. Right? We don't talk about levels of truthiness. Right? We're absolute when we're looking at this stuff. I like it. I like it. Okay. No shades of gray. All right. So let's take a step back before I get back into more truth tables. These are examples of simple statements. P and Q. In fact, any statement that can be represented by a single letter, P, Q, is a simple statement. So this statement is not a simple statement. So this simple statement would just be one idea conveyed. You only need one variable. To represent it. So the minute I say Sammy went to guitar lessons or Sylvia forgot to pay his bill, that is not a simple statement, because how many ideas are in that statement? There are two ideas in that statement, right? And don't you need a connector? You'd have to write it like this, P or Q. You need more than one symbol to represent that idea, right? So that's what we call a compound statement. A compound statement has more than one idea in it. Requires more than just a variable. Okay, cool. All right. You guys look a little more alive, even though I'm sure you guys are like, oh shit, what is this going to be like? To me, this is really cool. I know you guys think it's like the most evil thing in the world to mix math and English. But I actually taught this course linked with an English course before, and you're all like, thank God I didn't take that. But it was actually really cool. It was really cool, because they wrote papers on some of the stuff we talked about, and so they really freaking understood it a lot better. Because they had to write papers anyway. Might as well write papers on something you're supposed to know for another class. Bam, hello. Anyway, it went really well. So, let me give you this. A negation is its own thing. A negation. So, for example, if I said Jim did not pay rent, there's a not in there, right? So you can't just use the letter P to represent that. You'd have to use the symbol for negative, which for algebra a negative is a negative sign. For logic, a negation is just a squiggle. That's not P. So what would that mean then? What would P represent in this case? What would that statement be? No, I don't know what the value is. Do you know if Jim paid the rent? I don't even know Jim. Jim's my brother, actually. I don't know if he paid the rent, to be honest. Maybe he didn't.
Wouldn't it be Jim did pay rent?
Good. P would be Jim did pay rent. Because that is Jim did not. That's the opposite. That's the negation of what P would be. You guys kind of getting the idea. So this is a mixture of English and math, which is what... I don't want to say that, because then you'll give up on it. It's what math is. Math is a different language, so we're just translating from English to math. We're still doing that. You're always doing that. That's what algebra really is. Okay, so that's our first little, second symbol. Actually, I did or earlier, but that's our second symbol, negation. That's the negation symbol. So the negation symbol is this, and the or symbol, does anybody remember what that was? I put it up there without even explaining it. Yeah, because the thing I remember is you or you, I don't care who, do it. That's a V, right? You or you, do it. Shit. Just somebody. So it looks like a V. Looks like the symbol I would make. So that's or. Now let me ask you this. Before you get too far away from the negation. Let me ask you, what is the opposite of this statement? All, what do you want to say? All Chargers fans are hopeful. All right. What would not arguing anything about the idea behind that statement, what would the negation of that statement be? And you cannot just say all Chargers fans are not hopeful, because that's not true. It's not the negation. So think about it like this. If I ask you to write the negation of a statement like this, all or some or none, How would you show that this is wrong? That would be the negation. How would you show, if I thought all Chargers fans are hopeful, how would you show I'm wrong?
6 Charger fans are wrong.
Yeah, so be less specific than 6.
Most.
Just, not even most. You actually have to just show that at least one. So you could say some or at least one. So more generally, we would just say, so the negation of this, if this is P, not P would be some Chargers fans, what?
Are not hopeful.
Good, are not hopeful. You can spell, Jeff, can you? You just can't do punctuation. There it is. All right, let me let you absorb that for a second. Do you understand what I mean by if you wanted to show that the original statement was false? That thinking will lead you to what the negation must be. The opposite of this would be the situation that shows that this is false. That's what the opposite would be. Maybe. Because most people, when they see all Chargers, they say the negation is no Chargers fans are hopeful. No, it's way too far. You went way too far. You went to an extreme. You didn't have to go to an extreme. This is already an extreme. All Chargers fans, then you gotta go, no, at least one Chargers fan is not hopeful. That would be the opposite. How are we doing? No good? You alright? What's up? Are you guys alright? You're still like, I don't know about this class. I don't know, Jeff. I don't know about this class. Let me say this to you right now. You ready? One really nice thing with this class. I think I saw this class when I looked at the survey that most of you guys did. I think somebody in this class said one thing they didn't like about math was that if you miss one thing, it's going to be hard to catch up because everything builds on itself, right? This class, I've rearranged the chapters over the years, and I finally put them back in numerical order just because, right? But I could do chapter 9 before chapter 3, and then I could do chapter 7, and then I could do chapter 1, and then they don't build on each other. You with me? So it's not like normal algebra. If you totally didn't understand chapter 3, you could still have a really good shot at chapter 4, right? Because they don't have much to do with each other. All right. That's one thing. So I don't know if that helps or hurts. Because like, oh, shit, man, they're all separate. No, come on. And I also understand that some of you guys are taking this course just to check off your list, right? You need 120 to get that degree. All right, let me check that damn thing off. And you're like, this guy is standing in my way for me to check that off. No. This is still important stuff. I can't make you totally believe that. But there are uses for this stuff. And I know you guys don't believe me. But learn as much as you can now. And then you'll be ready. What's luck? What is luck? Does anybody know what luck is? Yeah, it involves chance. Luck is having the right skill at the right time. That's what luck is, right? Somebody came in and said, I'll give $1,000 to somebody if they can play guitar for me for a few minutes. Our guitar guy is sick. And you knew how to play the guitar. You're lucky. Holy shit, I get $1,000. Hell yeah. I don't know how to play a freaking good look. You can tell I don't have a clue how to play guitar. I don't have a clue. I have a guitar in my house that I thought I was going to learn, and then no, it didn't happen. Oh well. You guys kind of understand what I mean? So even if you don't know why you have to take this course, you don't know why you have to learn this stuff, the more you know, the luckier you will be, because the more skills you will have, the more shit you'll be able to understand. All right? Anyway, I'll stop. Blah, 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 blah. So what about this? What if I said some math teachers talk a lot? What would the negation be? That's P. What would not P be? What do you think? How would you show that it's wrong? What would you have to do? If I said some math teachers talk too much, how would you show that I'm wrong? What's the only way you can show that I'm wrong?
All. Couldn't you go either way, all or none?
It'd have to be none because some would be still included in all.
Exactly. If you showed that all of them, then I'm still right. Are some of the people in this room sitting down? Yes. Some of the people in this room are sitting down because we're all freaking sitting down. So some of us are. Are 3 people in this room sitting down? Yeah, of course, because there's a lot of people and everybody's sitting down. You guys understand? So I like the way you said it. All contains some. So it can't be the opposite. So if I think some math teachers talk a lot, the only way to show I'm wrong is to show that no math teachers talk a lot. Right? And you're like, you talk a lot, dude. So no math teachers. talk a lot. Okay, cool. I like it. Okay, I like it. So there's that idea. And on page 96, they give you this little thing. I'll recreate it up here for the bookless amongst us. The opposite of all are is some or not. The opposite of, let me do it the same way they did. Some are is none are. So the opposite of all are is some aren't. The opposite of some are is none are, just like we did over there. You know, you won't have the word are in there, but you get the idea. Maybe. So there's that little piece. It's going to be a little piece of the homework is going to be these four kind of expressions, right? And then the rest of the homework is going to be related to the P's and the Q's stuff. Stay with me now. Oh, all right. So let's come back. Let's formalize the next level here of compound statements. So simple statements. Is this a simple statement? Yes, I gave it away because how many letters did I use to describe it? One. Just one symbol. Is this a simple statement?
Yes.
How many symbols did I need to describe it? How many symbols did I need?
2.
2 symbols. So it's a compound statement. A simple statement only requires one variable. One symbol. Let me say it like that. How many symbols are there? 2. So it's a compound statement. I like it. Cool. Don't let that be a place you make a mistake.
So whenever there's like an answer, like how like some math teachers talk a lot, and then you wanted to negate.
Oh, the instructions would say, write the negation of this.
Okay, so.
That's why I wrote the negation. That's what the instructions would say.
Okay, so the negation would be.
This.
Guaranteed two symbols.
Definitely. Well, it depends. If that was what they said, write the negation of this. If they said write the negation of this, then it would only need one. So be careful. Is that cool? So any negation, anything has what's the word? An overt no. Anything that has a explicit no is a negation. It's automatically a compound statement. I like it.
What if you started with something like no math teachers talk a lot, right? The negation
What?
of this.
Exactly. If I would have said that, you would have written this. Because what's the opposite of none? Are. Some are.
Okay.
So if I said, what's the opposite of no iguanas? Iguanas? I like that. No iguanas like bats. What's the opposite of that statement? Some iguanas like that. Because, again, if you're ever confused and you don't want to memorize, because I personally hate memorizing shit. Math is not about memorizing shit, thank God. If it was, I would not have made it very far, because my brain's already basically full, right? So math is not about memorizing stuff. The people that think it is are the people that do bad at it. Math is about seeing the underlying idea and realizing that 800 problems are all the same damn problem. You just got to recognize what they're connected by. If you can't remember the rule, just think, how would I show? If somebody believed this, what would I have to show them they're wrong? If they felt that no iguanas like bass, I just got to find some iguanas that like bass. And then they're wrong. I show them they're wrong. That's the way you think about it when I say find the negation. Some iguanas like bass. Which one of these is a compound statement? Or are they both simple statements?
You haven't given us context yet. If one is a statement, then
Yeah. So anything with an overt no or none or not has got to have a not in it. It's got to have a negation symbol, right? If it's got an overt no or not, yeah. So this is P, then this would be not P. Cool. I like it. So first dude is going to be a compound statement. All right. So that's one little piece of the homework is the sum and the not, and none and the all, those kind of things. Yes, ma'am?
How is that a compound statement though? If it's no iguanas like bats, isn't it just like one idea? Like how are there two?
Well, it's got an overt no in it. It's got a not, like something related to a negation. So it's the negation of math teachers talk a lot. The negation of that is no math teachers talk a lot.
So you're starting the problem with the negation, then that means the other one has to be just normal P. That's what I'm confused about too.
Yeah. So what would the negation of the negation be?
Is that what it looks like?
Sure, that's the negation of a negation. What would that be? What do the two negatives do? Cancels. And then the other one must be, yeah.
Alright.
The opposite of an opposite must be the original, right?
So what is the?
It's whatever statement we're looking at.
Okay.
Yeah, it's a statement by itself in its purest form without any no's or nots in it. Yes?
So the negation symbol will only go in front of something that is no.
Yes, cool. Unless you're telling somebody, okay, you got to be. Now I want you to do this to it, right? So then it would reference something as a not in it or a no in it. Yeah, cool. All right. So here's the next level to this. Well, we already talked about or. Well, let's finish out about or. I'm not as concerned with terminology as I am with being able to do stuff. But officially, the or is called a disjunction. Right? Reminds me of the old Schoolhouse Rock. Conjunction, junction, what's your function? There you go. All right, got some people rocking out. Good. Because the and we'll see is a conjunction. Or uses the symbol this. We already saw that. And we even saw its truth table. So I'm not going to draw that again. I like it. So or is called a disjunction. It uses this symbol. So whenever you see an or, it's automatically a compound statement. You automatically have at least P and Q involved, right? Okay. And statements, like I just said, they're conjunctions.